India has achieved a historic feat for humanity's exploration of the Moon by landing a spacecraft near the lunar South Pole for the first time. With that, India has joined the USA, Russia, and China as the only countries to have achieved a soft landing on the Moon. But more importantly, it has become the first country to land near the lunar South Pole, a possible location for future Moon bases. This is the main goal of Chandrayaan-3, India's third lunar mission, which was launched on July 15, 2023. The lunar South Pole is a unique and challenging region where the temperature can vary from -10 degrees to 60 degrees Celsius depending on the depth, and where there might be water ice trapped in the permanently shadowed craters. Water ice is very important for future lunar missions because it can be used as a source of drinking water, oxygen, and rocket fuel. Chandrayaan-3 aims to study the lunar environment and resources around the South Pole and to measure the temperature profile and chemical composition of the lunar soil. In this video, we will discuss how did they do it, what have they found so far, and what are their plans for the future. Let's find out. Chandrayaan-3 is India's third lunar mission and the first one to land near the South Pole. It is part of India's ambitious space program, which started in 1962 with the launch of its first rocket from a fishing village called Thumba. Since then, India has launched many satellites, rockets, and probes into space, and has become one of the leading spacefaring nations in the world. India's first lunar mission was Chandrayaan-1, which was launched in 2008. It orbited around the Moon for almost a year and sent back valuable data and images of the lunar surface. It also carried a small probe called the Moon Impact Probe, which was deliberately crashed into the South Pole region and detected traces of water molecules in the lunar atmosphere. India's second lunar mission was Chandrayaan-2, which was launched in 2019. It consisted of an orbiter, a lander called Vikram, and a rover called Pragyan. The orbiter is still circling around the Moon and has the best resolution camera around our natural satellite. The lander and the rover were supposed to touch down near the South Pole, but unfortunately, they lost contact with Earth during the final descent and crashed on the lunar surface. India did not give up on its dream of landing on the South Pole. It decided to launch Chandrayaan-3, which is essentially a replica of Chandrayaan-2's lander and rover, with some improvements and modifications. Chandrayaan-3 was launched on July 15, 2023, from India's Satish Dhawan Space Center. It took about a month to reach the Moon's orbit, where it performed several maneuvers to adjust its trajectory and altitude. On August 20, 2023, it began its final descent towards the South Pole region, where no other spacecraft has ever landed before. The landing was very challenging and risky because of several factors. First of all, there was a communication delay of about 3 seconds between Earth and the Moon, which meant that Chandrayaan-3 had to rely on its own onboard computer and sensors to navigate and control its speed and direction. Second, there was no detailed map of the landing site available, which meant that Chandrayaan-3 had to use its own camera and radar to scan the terrain and avoid obstacles such as rocks and craters. Third, there was very little sunlight available at the South Pole region, which meant that Chandrayaan-3 had to use its own batteries and solar panels to power its systems and instruments. Despite these difficulties, Chandrayaan-3 successfully landed near the South Pole on August 20, 2023. It sent back its first image of the lunar far side area shortly after landing. It also deployed its rover, called Pragyan, which means wisdom in Sanskrit, which rolled out of the lander after 1 hour. The lander and the rover then started their scientific mission on the Moon. Chandrayaan-3 has two main objectives: to demonstrate India's capability of soft landing and roving on the Moon, and to conduct scientific experiments to study the lunar environment and resources. To achieve these objectives, Chandrayaan-3 carries 14 payloads on board the lander and the rover, which are designed to measure various aspects of the lunar surface and subsurface, such as temperature, radiation, seismic activity, mineralogy, and chemistry. One of the most important payloads on board the lander is called CHASTI, which stands for Chandra's Surface Thermophysical Experiment. It is a device that has a rod-like probe that can penetrate up to 10 centimeters into the lunar soil and measure its temperature profile at different depths. This is the first time that such an experiment has been done on the lunar South Pole region, where the temperature can vary from 10 degrees to 60 degrees Celsius depending on the depth. The data collected by CHASTI can help us estimate how deep the water ice is buried under the soil and how much of it is available for future exploration and utilization. Another important payload on board the lander is called the LRA, which stands for Lunar Retroreflector Array. It is a device that has 8 mirrors that can reflect laser beams from Earth or other spacecraft. It can be used to measure the distance between Earth and the Moon with high accuracy and to test Einstein's theory of general relativity. It can also detect some low-frequency radio signals from the far side of the Moon, which could reveal clues about its origin and evolution. The rover Pragyan also carries some interesting payloads, such as the APXS, which stands for Alpha Particle X-ray Spectrometer. It is a device that can analyze the chemical composition of the lunar rocks and soil by bombarding them with alpha particles and X-rays. It can help us identify the minerals and elements that are present on the lunar surface and understand their distribution and formation. Another payload on board the rover is called LIBS, which stands for Laser-Induced Breakdown Spectroscopy. It is a device that can vaporize a small amount of lunar material by using a powerful laser beam and then analyze its spectrum by using a spectrometer. It can help us determine the abundance and isotopic ratios of different elements on the lunar surface and compare them with those on Earth. These are just some of the examples of the scientific results obtained by Chandrayaan 3 so far. The Indian Space Agency has been sharing these results with the public through its official website and its X, formerly known as Twitter, account. These images show how Chandrayaan 3 is providing valuable insights into the lunar surface and subsurface, and how it is contributing to our understanding of the Moon.